We have lesson 4-3 now, properties of exponents. This is on page 170 in your book. And we are going to add one more property from what we had learned last year. So I'll review the two we learned last year, which are the multiplication property of exponents and the division property of exponents, and then we'll this year also talk about raising a power to a power, which means taking one exponent to another exponent. So I'm going to give you examples for all three of those, and then I'll give you some problems to try. So when you are multiplying exponents, numbers in exponential form that have the same base, there is this property that makes it pretty easy to do. So if we say we have a to the m times a to the n. So a can be anything you want it to be, but notice it has to be the same base. That's important. If you do that, we can actually just add our exponents and say that our answer will be a to the power of m plus n. So let me show you what that looks like with some numbers thrown in. So we have the same base of 2. That base is still in our answer. We would say we're going to add our exponents, and our final answer there would be 2 to the power of 5. I'm going to show you why that is now. So if we have 2 to the power of 3, that means we're multiplying 2's and we have 3 of them. If here we are having 2 squared, means we're multiplying 2's and we have 2 of them. When you're multiplying things like that, you can do it in any order you want. So we can look at this as just being that. And again, we're multiplying 2's. How many of them do we have? 5. So you can see those are the same. If you forget what the property of multiplying exponents are, you could write this out and figure out pretty quickly, realizing that you have 5 2's and your exponents were 3 and 2, that you would add those exponents together to get your exponent of 5. Let me give you a few more examples what this looks like. So if we have 5 to the 4th times 5 to the 3rd, we have the same base, so you keep the base and you add the two exponents. So we would have 5 to the 7th power there. The next example here looks like this, a to the 12th times a to the 12th. Same base, so we keep that same base of a. We add our two exponents, so we would have a to the 24th power. Next, we have 16 times 16 to the negative 7th power. Remember, you can have negative exponents, as we learned about in the last section. Remember also that if there isn't an exponent, the exponent is understood to be 1. The reason that is our base is 16, and we have 1/16, so that's our exponent. When we multiply these, again, we are going to add our two exponents. Remember SADs here. And we would have 16 to the negative 6th power. Last example is a little trick example here. We have 4 squared times 3 squared. When you have a problem like this, there's nothing you can do in using that property of multiplying exponents. So this is actually just our answer. This will not change. That's our answer, 4 squared times 3 squared. Watch out that you have the same base in order to use that rule. If you do not, you can't use the rule. Next rule is division. So this time we are going to be dividing numbers that are written in exponential form called powers. So if we take, I'm going to use the same letters I did before, if we take a to the mth power divided by a to the nth power, that's an n there, we this time are going to take our base and then raise it to the top exponent minus the bottom exponent. Super important that you remember that you always put the top exponent first. I think everybody's natural intuition says that they should put the larger number first and then the smaller number because that's how you normally subtract. You need to remember that you guys know how to deal with negative numbers. So it's not always going to be the bigger number minus the smaller number. It might be the smaller number minus the bigger number, and then you end up with a negative number. So that can happen, but what you need to know about this rule is it is always the exponent that goes with your top number minus the exponent that goes with your bottom number. So we have a to the m minus n. Let me show you why that is for this case. If we had 2 to the third over 2 squared, think about this expanded. Here we have 3 2's, here we have 2 2's, 2 2. Anything that's on the top and the bottom is going to cancel out. And you notice that we are left with that 1 2, could be 2 over 1, which is just 2. If we use our rule here, we would say our base is 2, our top exponent minus our bottom exponent. We have 2 to the first power, which again is 2. So just like with the multiplication property, if you forget what the rule is for division, you could write this one out real quick and think about what's happening here, and you'll hopefully be able to then realize, okay, well, I'm supposed to have 1 2 left, so how would I get to 1 when I started with 3 and 2? Well, I'd subtract, right? So thinking about an example with smaller numbers like this will help you to figure out problems with bigger numbers that you don't necessarily want to write out the whole thing. Now on to some division examples here. So say we have 10 to the 8th power over 10 to the 5th power. When you do these problems, you don't actually have to get a standard form answer. You're going to be asked to get an answer in exponential form, which means you should still have an exponent in your answer. So we are simply going to take our base, take our top exponent minus our bottom exponent, and get our exponential form answer, which is 10 cubed here. Next one, we have x to the 4th over x to the 9th. And here's an example where you are going to end up with a negative exponent because we have 4 minus 9, which would be negative 5. So x to the negative 5th would be your answer there. The next rule that we're going to talk about, and we did not talk about this one last year, so this is new. This is when you take a power to another power, and what that means is we have x to the, say, a power, and we're going to take that whole thing to the power of b. What you do here is multiply your two exponents. So when you multiply those two exponents, it will give you a more simplified answer. Showing you an example, we can say I have 2 cubed, and then we're going to square that. So what happens within these parentheses is we're multiplying 2's, and we have 3 of them. When we square that, that means that we have 2 of these. So we would say this times this. If you count up how many 2's you have there, we have 6. So think back to the rule and our original exponents being 3 and 2. those original exponents were 3 and 2, and we know our answer should have 6. Well, what do? We multiply, just like the rule says. So here we could say 2 to the 3 times 2, which would be 2 to the power of 6. And notice we got the same answer there. I'm going to show you a few of these examples, and then you guys should be ready to rock and roll some of these problems. First one is 7 to the 5th power taken to the 3rd power cubed. So we are going to take those two exponents. Notice you don't have to worry about whether or not you have the same base here because we only have one base. So you have 7 and your two exponents are 5 and 3. Ooh, can't reach. Which means you have 7 to the 15th power. Next up, we have 8 to the 9th taken to the 11th power. So you are going to have your base be 8, multiply your two exponents, and you get 8 to the 99th power. Again, we do not have to then multiply 99 eighths. I wouldn't ask you to do that. All you need to do for your answers on these is put the answer in exponential form. You do not have to get standard form answer. Next up, we have 2 taken to the -7th to the -2nd. When we multiply here, remember it's fun. So we're multiplying a negative times a negative, which is a positive. So in this case, we would get 2 to the 14th power. And last example is x to the 10th. And we are going to take that to the -6th power. So we are going to have our base as x, multiply positive times negative is negative. So our answer here will be x to the -60th power. When you guys flip to page 172, you're going to see essentially a lot of problems that look just like the ones that we just did. What I would like you to do is page 172, and I want you to do numbers 25 to 39 odd. That so you can see it better. So page 172, 25 to 39 odd. Please remember with the multiplication and the division rules for exponents or powers, you have to have the same base. If you do not have the same base, like the one example that we did, then you can't combine them. It's already simplified. Also, please remember that your answer should be in exponential form here. Like I said, with this one, you do not then have to multiply 99 eighths. This is the answer I'm looking for. So I'm looking for answers that still have exponents in them. And this assignment I would like you to have done for Monday. I'll post the explanation of these problems on Monday, and then we will be ready for the next lesson. If you guys ever have any questions, feel free to ask them during our Zoom when we have it, or you can post on the discussion board in your math class on Rediker. If you don't have any questions, I will see you next week and have a fantastic weekend.